Hi everybody, welcome to Advanced Concepts Week 8. This week I'm going to be attempting to create kinetic sand and explain what it is and how it works. Kinetic sand is a dilatant material and it's made from about 98% ultrafine sand and 2% polydimethyl siloxane, also called dimethicone. A dilatant material is also referred to as a non-Newtonian fluid in which its viscosity increases under stress. The properties of kinetic sand allow it to be shaped into shapes and sliced into pieces using a knife. Then over the period of a few minutes, if left undisturbed, the shapes will collapse. The chemical formula for sand, which is the primary ingredient, is good old regular silica sand, which the chemical formula is SiO2, which is a silicon atom connected to two oxygen atoms, and that makes up 98% of the entire mixture of kinetic sand. So what's in the remaining 2%? This polymer coating that gives the kinetic sand its unique properties is called PDMS, or that's short for polydimethyl siloxane, which is also the main ingredient in silly putty. The PDMS coating makes the kinetic sand behave more like wet sand. It gives it the ability to be sculpted and eventually flow back apart. So what is PDMS? PDMS is a clear organic polymer with a relatively simple repeating section of C2H6OSI, and it forms the simplest of the family of polymerized organosilicon compounds, loosely referred to as silicones. And it's found in many things. But to break it down even more, when we're thinking about PDMS, consider that it's a flexible hydrophobic molecule in a long chain comprised of a silicon and an oxygen silicon non-organic midsection or belly with an organic nonpolar outer scaly surface made up of methyl groups, which are a carbon atom and 3 hydrogens pushing outwards. The silicon atoms are very large compared to the carbon and hydrogen atoms that are nearby. In fact, they're large enough to draw electron density away from the hydrogens, creating slight polarity and thereby providing the possibility of hydrogen bonding. Being hydrophobic, PDS presents a shiny outer surface that water rolls off of without wetting, and it keeps the sand particles from sticking to each other. It makes it a key ingredient in many other water repellent materials such as car washes and waxes. It also is found in surfactants, drugs, and as a foam reduction agent in oils, even in some cooking oils to reduce splattering. So as I just said, silicone doesn't actually refer to one specific material, but it's a group of materials containing the elements silicon and oxygen. Silicones are polymers. That means they're molecules made up of long chains of repeating units. Silicone oils have unique properties that they can be liquids flowing freely or semi-solids that flow slowly in the absence of pressure. But under stress, they act like rubbery solids. This characteristic is referred to as viscoelasticity. So similarly, when we're talking about kinetic sand, the polymer chains within the silicone oil make the sand particles stick together, giving you the ability to form them into a ball. But these silicone oil coated sand particles will only stick to each other and not to other surfaces, which makes it an ideal toy to play with without making a big mess. Okay, one more boring slide of chemistry until we get to the experiment. But in order to understand how the PDS can interact and form bonds with the sand or the silicon, the silica, I want to just briefly go over the chemical makeup of the silica. So in the silicon oxygen centers, each oxygen has lone electron pairs, creating lightly negative electron density. With the PDMS polymer being so flexible, the molecules are able to move around. So when the PDMS chains get close enough, they shift their parts around and lots of hydrogen bonds are able to occur between the PDS and the sand. These hydrogen bonds aren't actual chemical bonds, but they're an interaction that causes the molecules to stick together, thus the sand sticking together. Overall, hydrogen bonds are weaker than chemical bonds and can be easily broken. Also, the sand silicon dioxide bonds are very flexible, and these oxygens with their electrons are able to easily interact and form more bonds. Since the carbon-hydrogen tetrahedra are locked into tight angles, silicon-oxygen tetrahedron angles are formed within the silicon dioxide. And the varying angles of the hydrogen tetrahedra angles are able to orient themselves in such a way that hydrogen bonds are encouraged and more occur. Since the sand particles are so tiny, the individual interactions may be weak, but because they're so compact, it's harder to break them because more of these hydrogen bonds are able to form. And then as it's pulled apart, the weight of the sand particles can overcome the attraction of the hydrogen bonds, and the molecules then separate easily, flowing almost like a liquid. Okay, so let's try to make some kinetic sand. What I have here is just some plain sand that I got from Michael's. I have cornstarch, I have food coloring, and water, and also a little bit of Dawn. So I'm gonna start by mixing a little bit of dish soap in with the water. I didn't really have specific instructions, so I'm just kind of going by like compilation of different other people's videos that I saw. I'm just gonna add some cornstarch, then I'm gonna add some of this mixture. Actually, let me mix this a little bit so that the soap can get in there too. And I want to just mix this up really good before I mix it with the sand. It's definitely getting all over. Oh, that's what vacuums are for. Add a little more. Get this mixed. It's like lumpy pancake batter. Well, not yet, but I guess it will be. I guess we don't want to make it too wet. So I'm going to keep on adding just a little bit more. Actually, I'm just going to add a squirt of this Dawn right in there because I'm not sure that the soap mixed with the water is mixing in enough. I may have too much cornstarch, I'm not sure. So I guess just because I prepare it all doesn't mean I have to use it all, does it? So keep mixing. And it is pretty thick consistency. Might end up just putting my hands in there. First, let me just add a couple drops of food coloring. I don't know if it really makes much difference. My sand is gray to begin with, but we might as well go all in. I never did this when I was a kid, so kind of having a little fun with it. Okay, looks like I might need just a little bit more water. All right, well, I'm gonna just go in and use my hands now. Mix this. You could see the consistency is pretty thick. It's like cookie dough. I have no idea if this is gonna work or not, but I'm just gonna put this on my sand and just start giving it a mix. I'm gonna use my hands to mix it up. Just mix it really good. Hopefully my hands don't turn too green.
I can see it's starting to form, sticking together. It doesn't look that pretty, but maybe if I bought some prettier sand right off the bat. I know they come in all different colors, like neon, but you could see here that it looks like my sand, the cornstarch with the water and the dish soap, apparently surrounded the sand particles, and I have some sort of kinetic sand. I don't know like if it rebounds quite the way. It doesn't ooze. So I guess I kind of got a partial result. I don't know. Sorry about this iron. I'm gonna add a little more dish soap just to see if I can make it any more gooey. Well, I guess I'd have to experiment with it some more because mine came out a little messy. But as you could see, I guess overall I did have a positive result, but I don't think it's exactly where I want it to be. But for the sake of the length of this video, I'm gonna stop here and maybe I'll continue playing with it on my own.